Alright guys, our next lesson is going to be on standard normal distribution. What the situation is going to be is we're going to have a set of data. This set of data is going to follow this bell curve. What this means is underneath the curve in your x-axis, in this area you're going to have a certain number of your percent of your data. In this area you're going to have another certain percent. Half your data is going to be to the right, half your data is going to be to the left. Alright, so you're going to have a set of data that fits into this curve. Some call it a bell curve. Right, so what we're going to have to deal with is think about a test. A test that we have thousands and thousands of people take. The average grade is probably going to be a C, where most people will score right around a C. Less people will score a B, less people will score an A. And this is a C, less people will score a D, and less people will score an F. Most of your data is right around the middle of your grades. All right, so that's the situation. To set this up, what you're going to have to be able to do is you're going to have to be able to draw the curve and draw these 5 lines. One in the middle, a little bit, where there's some data over here. There's a little bit of space here, some space here and here. All right, once we draw that, our mean is going to be that value in the middle. All right, whatever the data has an average over the mean is going to go in the middle. And then what's going to happen is this first line is going to be 1 standard deviation away from the mean. My second line is going to be 2 standard deviations. And way over here, we're going to draw a third line. There's almost nothing underneath it. It's going to be 3 standard deviations, because the further you get away from the mean, the less numbers, the less data you're going to have underneath it. And then we'll go the other direction. 1 standard deviation, 2, and 3. All right, so as you go, most of the data is between -1 and 1 standard deviation from the mean, right here in the middle. Then less and less, and a little baby bit over here. All right, so when we deal with this, we're going to have certain percentages that go in each spot. In this first one, from my mean to my first standard deviation, this area here is going to have 34% of the data. Also, on the other side, we're going to have 34% of data. So between the -1 and the mean, -1 standard deviation, our mean is 34%. From our mean to 1 standard deviation, 34%. So in between 1 standard deviation is 68% of my data. The next value is 13.5%. All right, and that is going to be here. There's 34 and 13.5, and then on the other side, we also have 13.5% of the data in this spot. So 34%, 13.5, and outside of 2 standard deviations, it's going to be 2.5%. The rest over here, and keeps going. And then the other side. So outside of 2 standard deviations, outside of 2, both sides is 2.5% each way. You need to memorize these. 34, 13.5, 2.5. If you add these together, 2.5, 13.5 is 16, plus 34 is 34%, or plus 34 is 50%. So the data to the right of my mean is going to be 50% of my data. 34, 13.5, and 2.5. 34, and the same thing on the other side is the other half of the data. These numbers you need to memorize, because we're going to have a mean, we're going to have standard deviations, or we're going to draw this picture, and then we're going to figure out what percent of the data falls in each area. All right, like this. All right, a survey said, let's say survey, not surveyed. A survey said that the average time spent at meals in a week is 13 hours. The standard deviation was 3 hours. I'm going to ask you to draw the normal curve and label the x-axis. All right, so there was a survey put out asking how long people eat meals during a week, breakfast, lunch, and dinner. The average time spent on our meals was 13 hours, and the standard deviation is 3 hours. So what we're going to do is we're going to put 13 in the middle, and then we're going to go 3 standard deviations, or we'll do 2 standard deviations in both directions. 13 is the middle, up 3 and up 3. 13, down 3, down 3. So 7 is 2 standard deviations away from 13. which would be a z-score of -2. If you remember z-score, it's how many standard deviations you are away from the mean. 16 is 1 standard deviation away from the mean, so this would be a z-score of 1. All right, so we're going to draw the curve best we can. We'll go to the middle and we'll do 2 lines. If you draw a third, that's fine, but you don't always have to. It all depends on what numbers you're dealing with. So I went 13, add 3, 13, subtract 3, subtract 3. So 7 is 2 standard deviations below. So what are the values 1 standard deviation away from the mean? And if we're talking about 1 standard deviation away from the mean, that would be subtracting 1 and adding 1, and we'd say 10 and 16. So the numbers 10 and 16 are 1 standard deviation away from the mean. What percent of the responses would you expect from 10 to 16 hours? So if we took all the people who did the survey, and we're trying to figure out what percent of the people ate between 10 and 16 hours, if we go back to the last slide, if you remember, in each of these sections is 34% of my data. Down 1 and down up. So we would say that between 16 or 10 and 16 hours, add those two together, we'd say 68% of the people eat between 10 and 16 hours. So in a week, it takes them 10 to 16 hours to eat all of their meals. So we're going to draw the curve, put the mean in the middle, add 2 standard deviations, subtract 2 standard deviations, and that gives us our values. This next block would be 13.5, and the next one would have been 2.5 if needed. All right, mean, and then count up and down 2 standard deviations. All right, the next one, the average grade for a class of 180 students was 76.4 with a standard deviation of 8.4. Not all statistics fall into a normal curve, okay? For the ones we're doing today, we're going to deal with a normal curve. And it'll say so in a problem. All right, so normal curve have most of the data around the mean, and then it tapers off as you go each way. So 180 students, 76.4 is a standard with a standard deviation of 8.2. All right, so we're going to draw the curve. We're going to add and subtract standard deviation. So 76.4 plus my standard deviation is 84.6. 84.6 plus another standard deviation is 92.8. And I'm going to do the same thing down. 68.2, my mean, 84.6 and 92.8. 1 and 2 standard deviations above. 1 and 2 standard deviations below. All right, so I'm asking you to find the number of students within 1 standard deviation of the mean. So if I want that, this is what I want. I want all the people here and all the people here. All right, our last problem said, because same idea, from within 1 standard deviation is going to be 68% of my data. So the first problem, I'm dealing with these two. All right, so 68% of my data falls within 1 standard deviation of the mean. All right, that's what we need to realize. All right, so if I could type, it'd be better, of the data. All right, so if 68% falls within the data and I had a total of 180 students, I'm going to take 68%, 0.68, multiply it times my 180 students, and give me a second while I go get a calculator. All right, I typed that into the calculator, and that's going to equal 122.4, but we don't talk about 0.4 people, so we're going to say 122 people scored within 1 standard deviation of the mean. And that's what we'd say our answer was. 122 people. So I picked 64% or 68% because between these two values, I multiplied 0.68, which is 68%, times my number of students, and it told me how many. The second problem says the number of students less than 1 standard deviation below the mean. All right, so for this problem, less than 1 standard deviation below the mean. So what I want to do is I want to know what percent of the people scored over here, because that's less than 1 standard deviation below the mean. So I go one below, and I want everything less. Dealing with our percentages over there are 2.5% plus my 13.5%, because that's the percentages for this area and the rest, which is 16%. So I'm going to take 16% times my 180 students, and I'm going to get 28.8, which we're going to say is 29 students. The big thing here is understanding what percentages we're working with. Since I want less than 1 standard deviation below, I want this area over here, which is 2.5, 2.5, and 13.5, going back to here. 2.5 and 13.5, which is my 16%, and 16% of my 180 students is 29. All right, now find me the number of students more than 2 standard deviations above the mean. The number of students more than 2 standard deviations above the mean. So what I'm looking at are all these people. More than 2 standard deviations above. If you look underneath this curve, this little area, there's not much room, so there shouldn't be many students. Where underneath this part of the curve is a lot of room, so there's going to be more students. So my math, 2.5% is 0.025 times my number of students, and that's going to equal 4.5, which we're going to call 5 students, because there's not much room underneath that curve. A little bit over here, it's going to be very few students, where over here, this area, under this, from here to here, was a whole bunch of students. That's why it's 122. So the area under the curve tells you how many students for this problem fit the criteria. All right, the last part. It said that normally distributed with a mean of 300, standard deviation of 20, so I counted by 20s. And what we're going to do is we're going to find the probability that a value selected at random is in a given interval. All right, this is going to be a Desmos problem. All right, so if I want from 290 to 305, I want from here 290 to 305, somewhere in here. Okay, I want all of these students. Let me draw a better line. Let's say this to here. Not exact, but close enough. All right, so I want all of these students and all these students. It doesn't fall on one of my standard deviations. All right, so what we're going to do is we're going to come over here, get out our thing, and we're going to go to our functions, distribution, normal distribution. All right, the first thing they want is the mean. Our mean was 300. Our standard deviation was 20. All right, so we get this graph. I'm going to hit my little zoom fit, and it's going to give me what's going on. So I got the same basic picture that I have here. What they want to know is how many people fall in this area. So what we're going to do is we're going to hit find cumulative probability. My minimum value I want is 290. My maximum value we said was 305. And there's going to be my answer. So it says 0.290 rounding 3 places just in our head, 0.290, which we're going to make 29.0%. That's the probability between 290 and 305. So over here, and this is what they've drawn. They've drawn the picture for us. From 290 to 305, they want this shaded area with a mean of 300 and standard deviation of 20. All right, so we're going to go 3 places, move our decimal place twice to make it a percentage. All right, the next one they want, let's get rid of this. And if you notice, when you click out of it, barely you can see it's a negative infinity to infinity. All right, so greater than 295. So I'm looking from, let me get a different color, from here and greater. So everything over here. So going back to the calculator, my minimum is 295. And I want everything greater. Then I don't have to change this one because it goes to infinity. So this 3 places we'll say is 0.599. 0.599, which will make 59.9%. So looking at the picture over here, going back to Desmos, 50% is from 300 to the right, so I'm just a little bit past that, so I'm going to be a little bit over 50% of my data. We'll call it 59.9%. All right, less than 303. Less than 303 is I want to be at 303, which is about here, and go to the left. So my minimum still needs to be negative infinity. My max is going to be 303. So I'm from here, everything to the left, which we're going to call this 0.560. 0.560, which is 56.0%. All right, so for these, we don't have to know the percentages. We need to use a calculator or Desmos to do this. On a test or a quiz, whenever that may be, you'll have some that are good ones that you need to do by hand, and some that are not, which I'll allow you to use a calculator on. And then this 56% is a little bit over half again. All right, the last one goes from 277, somewhere, get that back. 277 is going to be from here to 283, which is here. So I'm imagining it's not going to be that big of a number. So my minimum is 277. My max is 283. That little bit there, 0.073, 0.073, which we will call 7.3%. All right, so what we're doing is we're finding what percent of the data falls into this certain area. So this lesson's a little bit quicker. It's understanding 34, 13.5, 2.5. Mean goes in the middle. Count up and down at least 2 standard deviations. And then read a problem, figure out what they need. All right, so here's your homework 2. That's 4, 6, 8, probably about 13 problems. Let's go ahead and get this done. Next lesson will be posted on Wednesday, which will be your review for the statistics. And Friday, what we'll do is you'll take a practice test. You'll do it on your own. At the end of probably Saturday, Friday afternoon, somewhere on there, I'll post a copy of the answer key, how I worked out every problem. And then you can check and kind of give yourself a general idea of how you would have done. What we'll do is hopefully the following week, if we're back in school, we'll spend a day going over the review, going over the lessons, doing what we need to clean it up, and sometimes, hopefully by the end of that week, we'll be able to take a test on our statistics. Again, if you have any questions, please email me, chat with me, do something, get in touch with me. But we need to get through this and have as much of this done as we can, so it makes our life a lot easier when we get back. All right, here's a copy of the problems. If you don't have your book, don't want to look at your book. All right, have a good day, and I will talk to everybody soon.